Good afternoon, everyone. Thank you for joining our webinar today on how to accelerate rail product development with the help of Abaqus and Simpack. So before we begin the webinar, I would like to give a brief introduction about our company, EDS Technologies. So we are one of the largest technology solutions providers in India with more than 30 years of business transformation experience. We also help transform businesses by enabling adoption of virtual twin, geospatial analytics, and 3D printing. We have introduced many technologies like 3D printing, VR, digital manufacturing for the first time to Indian customers. We are a trusted partner for more than 2,000 organizations across various industries such as automotive, rail, aerospace, defense, industrial equipment, mining, and others. We have dedicated regional teams who are reinforced by our regional and functional consultants. We are backed by strategic alliances with global leaders who are pioneers in their respective technology areas. We also have a widespread presence across 11 offices in India. We are an end-to-end technology solutions provider to our customers. So our first speaker for the day is Mr. Tejas. Tejas is a dynamic professional with over 5 years of experience in the field of finite element simulation. He is working currently as a senior application engineer handling simulation vertical for EDS Technologies. He also has a rich knowledge and experience in the field of FEA with both structures and CFD. He has worked on multiple projects such as implicit, explicit topology optimization, thermal and fluid flow analysis. He has a master's degree in automotive engineering from MS Ramaya University of Applied Sciences. So our second speaker is Mr. Anand. Anand specializes in multibody simulation with Simpack and finite element analysis with Abaqus solutions. He provides technical support and training to customers, helping them leverage these tools effectively for their engineering needs. Currently, he is working as Assistant Technical Manager at EDS Technologies. He has completed his post-graduation from Rajaram Bapu Institute of Technology, Maharashtra. Over to you, Tejas.
Yeah, good afternoon, everyone. Thanks for joining for today's webinar on accelerating railway product development with Abaqus and Simpack, basically structures and multibody dynamics. So myself, Tejas Kumar. Today we'll be taking you through the first half of the session, on the industry challenges, and we'll look at the simulation portfolio and how structural simulation is helping out the railway manufacturers, and also we'll look at few things on ModSim, modeling and simulation for lightweighting, that is conceptual design and simulation, and also we'll look at the capabilities of Abaqus, and my colleague will be taking you through the multi-body dynamics applications and its capabilities. So when we think about railways, we often imagine trains moving passengers from one destination to another, right? So it basically consists of it's more in broader aspect, it consists of the major stakeholders like train manufacturers. We have mobility services, infrastructure management, freight rails. So finally if you look at all the aspects, right? So it comes into common objective, where we need to have a higher reliability, improved safety, reducing the operating costs, and faster development time. So here simulation plays an essential role in helping out every one of these stakeholders to achieve these goals, basically. So train manufacturers today develop product for several transportation segments. So one is with the passenger transportation, where we have locomotives, high-speed trains, coaches. So, and when you look at the freight side, you have locomotives and wagons where you carry heavy loads under demanding operating conditions. So all these vehicles serve different purpose. So they all undergo similar engineering challenges, we should ensure the structural integrity, durability, passenger comfort, crashworthiness, and we also need to look at the compliance and the international standards. So instead of relying on the physical prototypes, so simulation allows you to evaluate the complete development cycle, basically much earlier in the development cycle. So in railway industry, the current undergoing transformation, what's happening. So manufacturers are expected to deliver the products like much in safer, lighter, and more energy efficient, while simultaneously reducing the development time or maybe the costs also. So one major trend is basically the electrification, where electric trains becoming more common. Engineers must evaluate the thermal behavior, thermal and structural interfaces, and battery systems, power electronics. And also, in addition to that, we have the structural performance of the entire system. So another important challenge is sustainable mobility, that comes to lightweighting of the structure, where you need to reduce the energy consumption and must you need to satisfy the durability of the component and its crashworthiness requirements. So passengers expect also they also expect the comfort, when you look at the ride quality of the railway and all those things. So, and also when you look at the testing standards, there are multiple testing standards that you need to pass through, for different crash simulations or multi-body dynamics. There are multiple testing standards, so those things should be evaluated before going into the actual manufacturing thing. So product development is no longer isolated into an individual software tool kind of thing. So modern engineering requires connected digital platform where design, simulation, and manufacturing works all together, collaboration together. So here the 3D experience platform provides exactly the engineers can create CAD models, perform structural simulations, and multi-body dynamics, and also collaborate across the global teams to manage the product data and in a single environment basically. So instead of transferring files between the disconnected software packages, engineer works within one digital ecosystem, which improves the traceability, reduces errors, and significantly shortens the development cycles basically. So railway engineering, it is inherently multidisciplinary. If you look at the railway product, it can't be designed using only structural alone or kind of thing, right? So engineers must evaluate the electromagnetic, structural strength, aerodynamics, cabin comfort, and also vehicle dynamics. So each answers a different engineering question, but together they ensure the safety, efficiency, and passenger comfort basically. So today's presentation will be focusing preliminarily on the structural capabilities and the multi-body dynamics of the solutions. So when you come to structural simulations, right? So the backbone of when you look at Abaqus as a backbone, right? So here we have multiple things where when you look at the structural simulations, right? So you need to have the stiffness evaluations, model analysis, durability analysis, nonlinear deformations, and joint performance. And also if you're looking at the design optimizations, material calibrations, different materials are used across the railway structure, the coaches for different products, right? So whether the component is a car body or a bogie frame or a suspension bracket or couplers, engineers should predict the stresses, deformations, and potential failures across every location basically. So this significantly reduces the redesigning at the later stages basically, when you already manufactured the product, prototype, or you built a prototype. So before that you'll be evaluating in the virtual phase. So to do that, we have something called modeling and simulation capability. So usually traditionally how it is done, basically the product development follows a sequential process where design was completed first and simulation comes later, where physical testing occurred at the end phase of the design basically, and there we'll get to know this is what we need to redesign and we need to do the things. So in ModSim, the ModSim changes the entire workflow, where modeling and simulation happens together from the earliest design stages. So engineers evaluate multiple concepts, optimize the designs, so and also identify the issues before the physical prototypes are built. So this will result in shorter development time, improve the performance, the product performance, and also by reducing the other development costs. So here we have a practical workflow of a train car body development basically. So engineers like can begin with kind of so they can begin with the parametric geometries where you have multiple parameters in place, and like kind of like if you consider a thickness as a parameter and few dimensions as a parameters, right? So you change the parameters, like it will change the entire board, like the structure basically. So that's how you build a parametric geometry, and like you take it into a finite element model where it automatically like meshes the entire structure with just one click. And again, if you need to change the parameters, you can change it, and the mesh will automatically change accordingly, like with the change in the model basically. And then you simulate for like different scenarios, like a payload kind of scenarios and other things. And again, you finally bring in the results. So once the results are out, again, if you need to change the parameters and other things, right? So you go with the DOE setup kind of design optimization like experiments basically. So DOA experiments kind of you change, give the minimum and maximum values for the parameters what you select for, and you set an objective. This is what my the main aim is to do, go with the final objective, maybe to withstand certain amount of load or to reduce the stresses, or to bring down the entire weight of the component. So finally it will give multiple results, like instead of going with like you can validate the concepts like kind of like multiple results. Instead of evaluating like fewer designs, the engineers can efficiently explore hundreds of alternatives and before coming to the manufacturing phase. So you can decide like going into the next phase basically. This is a concept phase where you can go with the engineering workflows. So now let's move on to like on specifically on Abaqus. So Abaqus is Simulia's flagship finite element analysis software, which is widely recognized as one of the most advanced nonlinear simulation platforms across the world. So it performs simulations like ranging from like a routine non-linear analysis to a non-linear analysis of it, sophisticated non-linear analysis, like when you include like hyperelastic kind of materials, viscoelastic kind of materials, so all the things. And for railway applications, Abaqus kind of like supports linear, non-linear structural, contact mechanics, fracture mechanics, composite materials, material calibration if you have a testing data kind of thing. So material calibrations, and also co-simulations with other engineering tools are also are possible. So, and we also have coupled simulations where like your thermal structural kind of simulations can also be performed. So this versatility kind of allows our simulation engineers to analyze everything from a small mechanical component to a complete rail vehicle, complete subsystems to a system level simulations. So, so is there anything? Okay. So when you look at Abaqus standard, it's an implicit solver preliminarily used for static, structural, dynamic analysis. So it is ideally for evaluating stresses, deflections, so natural frequencies, heat transfer, thermal structural coupling, acoustic behaviors. So typically railway applications include like car body strength assessments and fatigue evaluations, like a bogie frame analysis, model studies, which are required for the ride quality and regulatory compliances basically. So when you look at Abaqus explicit, so which is for high speed dynamic events, Abaqus explicit becomes like a preferred solution. So it is designed for analysis involving severe nonlinearities like complex contacts, large deformations. When you look at railway applications, it is mainly like used for crash worthiness and also the impact kind of analysis, derailment and events kind of thing, blast intrusion basically, and also the material failure kind of analysis, occupant safety studies. So all those things comes into picture. So explicit solver enables engineers to like simulate events that are extremely difficult or expensive to reproduce in the experimental way basically. And we also have these CLSPH and DM techniques where your fluids come into picture and other things. So those things can be evaluated. in a modern railway, right, increasingly using composite materials to reduce weight while maintaining the strength. So Abaqus offers a comprehensive composite simulation capabilities like uh, like apply-based modeling, delamination predictions, failure criteria, manufacturing simulations, draping analysis, so and also multi-scale material modeling. So these capabilities it helps like manufacturers confidently adopt the lighter lightweight composite structures basically. And we also have multiple things like buckling kind of analysis where you have these beams kind of structures where you go with the buckling analysis, and also micron macro modeling kind of capabilities are also possible. Beyond structural analysis, right? Abacus predicts the damage initiation and propagation within the composite structures. So engineers can evaluate the impact damage through like thickness stresses and optimize the laminate stacking kind of sequences before the manufacturing. So each how the stress is being like transferred from each layer basically. So that's where each stack has been like proper like the if the crack is propagated, right? So that's when you will get to know easily through composite simulations. So finally, like here we are having a several like kind of examples on railway engineering. So engineers they usually on the railway infrastructure where you can see infrastructure where the basically while the rail is moving, right? So under the body, like if you have any like pipelines or something, that this comes under infrastructure kind of thing. So how those are affected, or like if you look at the frequency analysis, like the vibrational studies of the rail track while during the movement. So and also the wheel rail contact interactions, and also the lateral resistant evaluations like for sleeper and blast performance kind of thing. The track structural assessment. So these simulations help to improve the infrastructure reliability and also optimize the maintenance and planning. And also this collectively these capabilities demonstrate how virtual like engineering enables manufacturers to reduce the development time while increasing the confidence in the product performance basically. So now I would like to like share an industrial real industrial application demonstrating how Abacus has been like successfully used in railway development. There is one of the example we came across uh, Stadler Rail, so one of the world's leading railway manufacturers. As many of you know, like rail vehicles must satisfy the stringent European um, crashworthiness standards, like particularly like EN 150, 1527. So which defines like several collision scenarios that train must be safely withstand. So these scenarios like it includes like kind of like a collision between two identical trains, and a collision with 18 freight of wagon load that is 80 ton of load basically, and a collision with large deformation deformable obstacles kind of thing. So all these conditions using the physical prototyping alone would require multiple expensive crash tests that needs to be performed. Instead, Stadler used Abacus unified element analysis to virtually design and optimize the complete crash structure basically. And the simulation focused on the components such as like the crash module, crash box, couplers, pillars, and crash walls basically. So ensuring the energy is absorbed within the controlled manner and while protecting the passenger compartments basically. And one particular impressive outcome that was that the physical validation test within approximately 10% of its simulation predictions, so demonstrating the high level of confidence in engineers that can be placed in Abacus as a result, like when you look at the results accuracy. So you can say like why Stadler choose Abacus, right? So the answer lies in the robustness and versatility of Abacus solver technology, where rail crash events involve highly nonlinear behaviors. Like during impact, components undergo large deformations, and also uh, during the impact the components, and like it goes under large deformation, multiple changing contact conditions, complex energy absorptions are been like observed during the crash, right? So Abaqus provides highly accurate a general contact algorithm, which is allowing engineers to model these continuously evolving contact conditions without like simplifying the physics in that particular environment. So same, the engineering models developed for a structural analysis can be extended for crash simulations and implicit and explicit solvers, like reducing model preparation time and improving the consistency basically. So here is a close relation between the virtual simulation and the physical testing. One with the left, we see the Abaqus simulation predicting how crash structure progressively deforms during the impact. And on the right, we can see the corresponding physical crash test that Stadler has performed in their uh, manufacturing. So one of the greatest advantage the simulation engineers that can visualize like exactly how the energy flows through the structure before the building and hardware kind of thing, and you can identify which component deforms first, whether the passenger survival space is like maintained, and whether the crash module absorbs the sufficient energy kind of thing, and also once virtual results demonstrated like accepts the performance of the, like when you compare with the physical and like the virtual tests, so that's when you look at the accuracy of the like the software, how it predicts the highly nonlinear kind of interactions. So ultimately, like simulation must provide a measurable benefits. uh, it may be business benefits, in these case studies, right? In Stadler, like basically Abaqus delivered several like benefits. First, it enabled more efficient product development process while meeting increasingly the demanding of the crashworthiness regulations, and the crash module like was successfully released for the production within 8 months after the contract signing basically, and significantly reducing the development time. So second, the optimized design successfully designed satisfied the prescribed collision scenarios that exceeded the required safety standards. Um, Finally, the simulation provided engineers with much deeper insights in the product behavior than the physical testing alone, right? So instead of evaluating one prototype configuration, multiple designs alternatives could be assessed virtually, enabling and the like engineers to go with the better decisions. Um, this is what the true value of simulation driven development has been uh, took place, like with fewer prototypes, faster development, and improved product performance, and with a greater confidence, Stadler has moved forward. So, so far we have seen Abaqus, how it helps engineers to understand um, structural behavior and railway components infrastructure, and how structural performance alone like doesn't fully describe how train behaves in the operations. So to accurately predict the vehicle dynamics and vehicle rail interactions, ride comfort, and system level performance, and multi-body simulations, like which becomes more essential. So with that, I would now like to hand over my to my colleague who will be demonstrating on the Simpack capabilities.
Yeah, thank you, Tejas.
Yeah, over to you, Anand.
Yeah, thank you. Okay, next slide.
Yeah.
Okay, so in railway vehicle dynamics, these are the all scenarios or load cases we can do. Like flexible track durability is there. Okay, we can have flexible track, like we can import it from the Abaqus, okay, from AP software into Simpack, and we can analyze that. Then we can go for the comfort analysis, okay, as per the EN standard. Then rail wheel wear analysis we can do. Then gauging analysis is there. critical speed analysis, okay, derailment analysis as per the EN standard. So these all scenarios are as per the EN standard. Also switches and crossings, okay. So this is means done in order to get the means we are doing it for the safe, reliable, and comfortable vehicle. So yeah, see this. Okay, so it's, before we yeah, next slide you. Next slide you can go. Next, yeah. Okay, so before we jump into that, what is Simpack rail and everything, so just a quick level cover the what is MBS, like a multi-body system simulation. So MBS helps us to study how a mechanical system moves and forces, and how forces act on it, even before building a physical prototype. So using MBS, we can simulate the motion, like understand positions, velocities, and accelerations of the parts. So we can predict the loads, like, and means like predict loads means we can calculate forces and movements acting on the components. Then optimize the design. Then optimize design means improve performance, safety, and durability by changing the parameters like stiffness, damping, and or geometry. So here, see, we can simplify the real. It simplify the real mechanical systems into abstracted models with the discrete bodies, joints, and force elements. Okay. So real mechanical systems are complex, and so in MBS we simplify them into mathematical models like bodies, okay, then joints. So bodies will can be discrete, rigid bodies, or flexible bodies, okay. Then joints define to allow the motion between the bodies, like revolute joint or prismatic joint or spherical joints. Then the force elements are there. They represent the physical effects like springs, dampers, bushing, and contacts. And here we see one example is there. So real model, and this is called as a MBS representation. So if we see these blocks represent the bodies, like wheel is represented by this rectangular block. Okay, then chassis is there. Tejas, can you mute?
Yes.
Sorry. Okay. Okay, so these blue colors are the joints which represent the degrees of freedom. For example, for this wheel, there is a rotational degrees of freedom. Okay, it can rotate about this axis, this lateral axis or y-axis, we can say here. These all are the blue color represent the joints. Then this red colors are the force elements. Okay, for this, for example, this spring damper is there. So for spring, we can represent with the this force element. Okay, we have force elements for the different types of springs and different types of dampers. Okay, so this way we will we can understand whole our system through this MBS representation, or we call it as a 2D topology in Simpack. And next slide. Next slide, Tejas. So yeah, previous. So MBS applications generally involve large motions, uh, translations and rotations. So the components often undergo large movements, including the significant translations and rotations. Okay, MBS formulations are specifically designed to handle large nonlinear motions accurately. Then there is efficient modeling using the rigid bodies and analytical elements. So modeling most components as the rigid bodies, which reduces the number of degrees of freedom, and using flexible bodies only where deformation significantly affects system behavior. For example, car body bending or long shafts are there. Then representing physical components with analytical force elements such as springs, dampers, bushings, and contact models. So this approach balances accuracy and simulation speed, allowing faster simulations even for complex systems. Simpack is used to predict and optimize the motion and loading of any mechanical or mechatronic system, even up into the acoustic range. And its applications are, so Tejas, you can just click, okay, automotive. Okay, first application is automotive, like ride, comfort, and handling analysis can be done. Then engine analysis, okay, whole engine simulations can be done. So it has almost 100 moving parts, so which is a very complex system. So we can also have flexible bodies. Then Simpack rail is there. So this is the first application of the Simpack, and Simpack is very strong in rail sector or rail domain. And in this railway applications, we can go for the critical speed calculation, derailment analysis. Okay. ride comfort analysis, gauging analysis. So these are the analysis we can do. So we will discuss. Then this offshore wind turbine is there. Then some other any type of rail vehicle. So it is different type of rail vehicle. It is a roller coaster here. Then this is a land machinery. Okay, and this last is general machinery. So if you see that flexibility of the ring is taken into consideration. Next slide, Tejas. Yeah, so see, Simpack has fast, accurate, robust, and versatile solver, which means enables the efficient modeling. So it has a native flexible body integration. It means simple flexible bodies like simple beam kind of bodies we can generate or we can create within Simpack itself. And complex bodies we can import from the FE software like Abaqus, we can import it. Then it has accurate and stable analysis of high frequency dynamics. It supports the multi-core. Then it is real-time capable. Next slide. Okay, what is Simpack Rail? Now we will discuss what is Simpack Rail. So Simpack Rail vehicle is a generic mechanism running on rails. So the Simpack Rail vehicle is modeled not as a specific train design, but as a generic multi-body mechanism that moves along the rails. So this means the vehicle is built from the standard mechanical elements such as the bodies, joints, force elements, and wheel rail contacts, which together represent the physical behavior of any rail vehicle. And what does generic mechanism mean? So the model is not limited to one vehicle type. Okay, like metro, locomotive, wagon, high-speed train, etc. We can model. So means users can configure different layouts by changing the number of cars and bodies, then suspension types like primary, secondary, or air spring, etc. Then we can change masses, stiffness properties, damping, and geometry. So the same modeling concept works for many railway applications. So what is running on rails? So the motion of the vehicle is constrained and guided by the rails. So it has access to the whole powerful Simpack technology and all library elements. This means that Simpack rail model is not limited or simplified tool, but has full access to complete Simpack multibody simulation environment. And what this whole powerful Simpack technology means? So advanced multibody dynamic solvers for large motions and non-linear behavior. Then it has accurate wheel rail contact models, for example, creep forces, normal forces, and contact geometry. So it supports it supports the rigid and flexible bodies. Then it has time and frequency domain simulations, also powerful post processing and visualization tools. So this allows engineers to simulate uh, realistic operating conditions with high accuracy. And what are library elements? So Simpack provides a wide range of predefined validated elements, such as joints are there, like revolutor, prismatic, or spherical joints. Then force elements are there for springs, dampers, bushings, air springs. Then wheel sets are there, bogie, suspension components. Okay, so these components are available, like again track elements, rail profiles, and irregularities. So some of these elements are available in the Simpack library. So it has also additional modeling elements like detailed coil spring. Okay. So next are we will see the typical applications of this Simpack. Like first is the critical speed. So due to the conicity of the wheels, so rail vehicles have a tendency to oscillate laterally. So up to a particular speed, the lateral oscillations are stable and damped, fading out over time. So above particular speed, the oscillations are no longer damped out and becoming unstable and growing in magnitude until a flange contact occurs. So this phenomena is known as hunting and can cause damage to the track and vehicle, so presenting a derailment risk. So the speed at which this starts to occur is known as critical speed. And we have two different methods for calculating this critical speed. First is linear and second is non-linear. So linear is just initial design phases. We can use this linear method, and non-linear is a realistic method. Okay, we can run the vehicle like two different approaches are there. So we can start our vehicle to run from the higher speed. Okay, then we can analyze it, and then second is approaches. We can start from the means the lower speed, and we can increase the speed, and we can check the critical speed. Next slide. Okay, so derailment. So this is safety against derailment is related to the ratio between the Y and Q forces. Okay, so Y is the lateral force between the wheel and rail, and Q is the vertical wheel rail contact. So this ratio tells us how likely the wheel plunge is to climb over the rail head. Okay, so Y by Q critical for derailment. So plunge climbing derailment occurs when the lateral forces when the lateral force Y pushing the wheel towards the rail is high, and the vertical load holding the wheel is on the rail is low. Okay, so critical use cases are defined to ensure that derailment will most likely not occur, and it is done as per the EN standard. Like for example, EN 14363, the vehicle has to run through a twist between the two bogies, and an additional twist is applied between the wheel sets of the first bogie. And here, if you see this plot we will get this plot for the Y by Q coefficient, and this red color line is the limit. Okay, so it should be between that limit. Then we can say, okay, this is safe. Yeah, next slide. Okay, next is the comfort analysis. So what is comfort? So comfort analysis in Simpack is performed to evaluate how comfortable a ride feels to passengers when the rail vehicle runs on a given track at a certain speed. So it focuses on vibrations and accelerations transmitted to the vehicle body, which directly affect the human comfort. Okay. And see, we will get these types of plots here means after doing that ride comfort analysis. So in the Simpack post we have a comfort filter, so after applying some other filters we will get these types of plots, and we will get this ride comfort index, and we can compare with our means standard value. Next slide. Okay, so means that for comfort analysis, so acceleration signals are required, and see vertical, lateral, and axial accelerations are required. So to determine an estimation of comfort, acceleration information is required, and there are three ways possible, like to calculate the acceleration. So with the sensor, then with control element type 167, and with result element type 167. Okay, so these are the three approaches or three ways which are available in Simpack. As also, if you have measured data of the actual rail track, then you can directly import it into Simpack post, and directly apply the that comfort filter here and other filters as per the standard, and you will get this right comfort index. Next slide. Okay, next is roll coefficient. So in static condition, okay, we'll get this roll coefficient. Like here, we will check this car body track angle and divide by this track ground. So here, by doing this, we will get the roll coefficient. So in static condition, we will check this roll coefficient. But when vehicle or this railway passes through these tunnels, okay, so in that case also we can, means that is called as a gauging analysis. We can check the distance between the walls and the railway vehicle. So that gauging analysis also we can do here. So different approaches are available in Simpack. Yeah, next slide. Yeah, next is so next we have add-on models to this Simpack rail. So first is Simpack rail wear. So wear in rail vehicles refers to the gradual removal of material from the wheel and rail contact surfaces due to the rolling and sliding during the operation. Okay, and two wear calculation methods are available, like Archer wear law and cross Paul wear law. Okay, so Archer wear law is widely used empirical model that relates material wear to the contact force and sliding distance between the two surfaces. And this Paul wear law is a railway specific wear model that improves upon Archer's law by explicitly considering the creep forces and creepages which dominate wheel rail wear. So it is especially suitable for railway wheel rail contacts. And process of updating profiles and means running through the calculation loops can be automated. So okay, go to next slide, Tejas. Okay, so here here we can see how means impact railway analysis is done. So you can see here this first is the model creation. Okay, we will create the means we will build the wheelset, bogies, and full coach or full rake level railway vehicle, and we will also build our load case scenario, like we will have this track here. Okay, And then next we will go for the dynamic simulation. Okay, we will run it on the track, and it will loop profiles. See, it will again get repeated, means how many number of times, means we will consider a specific track, okay, from to distance, okay, from one location to another location. We will take that track, and here we will run that vehicle as many times as we want, okay, as per our standard, and it will get repeated. So this is automated process, we need not to run it again and again. Okay, so once it will run, so mileage is completed, and then we will get the VR results. So number 5 is the VR results. Okay, so here we will see means how means material is removed, means in millimeters. Okay, in millimeters we will see at what distance how much material is removed. So will VR predicts aids in the better management of the vehicle maintenance. Yeah, next slide. So next add-on module is the Simpack Flex track or flexible track. Okay, so we can also analyze the tracks here by taking this flexible track from the AP software. So for it is useful for new track designs, then for bridges, turnouts, and crossings, it is very useful. So we can take the flexible tracks from the Abaqus here, and we can check how much stresses are coming. Okay. Next slide. Okay, so why do customers choose Simpack? So we will discuss the strength of this Simpack now. So there are challenges like means numerically and physically large models are there. So Simpack can handle numerically and physically large models up to 2000 degrees of freedom, means 2000 plus degrees of freedom, and many of them are the strongly non-linear. So we can have multiple coaches, trucks, axles, wheels, suspensions. Then we can also build the long trains and long tracks. So we can have the rail wheel contact non-linear and very steep contact like 5 raised to 8 Newton per meter stiffness. So it can have wheel load of hundreds of kilonewton. And next slide. Okay, then avoiding redundancy. So substructures means nothing but the Simpack models referenced by the file name. So here we can have unlimited number of nesting levels. For example, we can start from the building the wheel set, then we can go for the bogie modeling, and in bogie modeling we can use this wheel set twice as a substructure. Then this after bogie modeling we will go for this car body or coach modeling. In this coach we will use this bogie as a substructure twice, and then we will build this full rail vehicle. And next. Okay, so rail wheel contact modeling, there are two approaches. First is standard and second is advanced. So standard means equivalent elastic contact. So it determines the actual contact patch shapes, but does not use them directly for normal and tangential force calculation. So it converts the contact patch shape into an equivalent ellipse, which is comparable in area and produces forces comparable to the actual contact patch. Next, second is discrete elastic contact. So that will use the actual contact patch shape for the normal and tangential force calculations. Yeah, next slide. Okay, so for track definition, here vehicle can run on different tracks from the short segments up to several kilometers. So we can here means do the track layout, and we can also include the irregularity of the track. So various methods are available here. So track layouts can be modeled via direct input from the Simpack, or if you have major data, that also can be imported. So we can also model the track defects. We can also model the variable rail profiles for turnouts and crossings. Next slide. Next slide. Yeah, so there is means no limitations in what you model. See, setup of wheels here. We have different setup of wheel sets here. For example, see fixed wheel set. The wheels and axles both are fixed here. Then independent wheels, so wheels can rotate independently. Then this kind of arbitrary mechanism, you can see it here in this. Okay, this is the one application. Then this wheel alone, and then this arbitrary mechanism too is there. Okay, so for example, roller coaster, this can be used for roller coaster application. Next slide. Okay, again for setup of rails, we also have different types of rails like inertia fixed rails and rails on bodies. And here we can have each rail is a separate body. Okay, we can have roller rig here. You can see here, this is the roller rig in this animation. Okay, we can use it to test this railway vehicle. Then a single rail setup is there. Okay, each roller rig has a separate body we can use. So then again, more than two rail profiles in the same model also we can model. So these are the different ways we can set up the rails in Simpack. And next slide. Okay, so these are the suspension elements like detailed coil spring models, which is there for the suspension of the railway vehicle. Then in Simpack there is air spring system with pipe connections, level controls, and valves, etc. Okay, so detailed rail spring models are available in Simpack. Then elastomer springs, lead springs are available. Then contacts like a 2D and 3D contact we can define, and friction elements also we have here. So we have library of these elements. Yeah, next slide. Okay, who embarks? So that Simpack part is over. Now we will see this who embarks. So next slide. Okay, so first cap is there. So they are into designs and manufactures of the complex rail systems. Okay, and they are using this means 3D experience platform solution. So 3D experience platform centralize the product data and establish the robust configuration and change management. So they are using it for the railway vehicle designing purposes. Next. Next slide. Okay, next is Alstom. So they are using a Simpack for the railway vehicle dynamics applications. Okay, and they are doing all these load scenarios or use cases like which we discussed, means derailment analysis or this comfort ride comfort analysis. So they are mainly doing all this analysis by using this Simpack. Next slide. Okay, next is the Stadler. So they are so already Tejas has discussed about this. So they are using Abaqus for the crashworthiness analysis. Yes, and they are saying this Abaqus enabled us to reduce the product development times for the KISS cars while retaining high quality and safety. Okay, so mainly they are using Abaqus for their crashworthiness analysis of the railway vehicles. Yeah, next slide. Yeah, okay. So last slide of today's webinar, like summary of today's webinar, like we have industry challenges like low carbon solutions we need, like energy efficiency, battery trains, hydrogens. See, we by using this means Simpack and Abaqus, we can reduce the time to market. Okay, uh, then we can maximize the reuse and standardization through the modularization. So we can improve the business decisions based on the data and cross-discipline collaboration. Okay. And so key capabilities are the multidisciplinary collaborative platform, yeah, and then we have integrated, configured engineering and manufacturing for design efficiency. So we have modeling and simulation for the various for validation and certification. So we can also have means we can also go for automation and optimization by using this Simpack and Abaqus.
So I would like to thank the audience for joining us today for our webinar. We hope this has been an insightful session to you. I would like to also thank Tejas and Anand for delivering this presentation. So in case if anyone has any queries related to Abaqus or Simpack or any other rail simulation requirement, you can reach out to us either mail or via phone. Our contact details are displayed on the screen right now. You can either mail us or call us, and we'll be happy to address your queries. So once again, I'd like to thank Tejas, Anand, and our audience for joining this webinar. Thank you once again. See you at the next session.